In this video, we will understand the complete credit risk scoring and rating development process in very simple language. The entire process has 5 major steps: data collection and preprocessing, model fitting, model validation, definition and validation of risk ratings, and finally implementation, monitoring, and review. This process is not one time. It is iterative, meaning we may go back and improve earlier steps if needed. Let's start with data collection and preprocessing. This is the first and most important step. Here, we collect loan data for both performing loans and non-performing loans, where non-performing loans are those unpaid for more than 90 days. The data includes both quantitative information, which means numerical data, and qualitative information, which includes non-numeric factors. Before using the data, we clean it. This involves removing extreme outliers, selecting the most relevant risk variables, transforming data where necessary, reducing subjectivity, and ensuring consistency in the dataset. For consumer or retail loans, the data usually includes borrower income, assets, existing loan obligations, past payment history, employment status, collateral or guarantees, and the type of loan such as auto loan, credit card, or mortgage. For corporate borrowers, much more information is required. First, we analyze financial data by reviewing financial statements such as the balance sheet, income statement, and cash flow statement. We calculate profitability ratios like return on assets, return on equity, and profit margins to measure earning ability. We calculate solvency ratios like debt to equity and interest coverage ratio to measure long-term repayment ability. We also calculate liquidity ratios such as working capital, current ratio, and quick ratio to measure short-term repayment ability. In addition, management efficiency ratios like inventory turnover, receivables turnover, accounts payable turnover, and total asset turnover help assess operational performance. Next is transaction data, which gives a more updated picture of business activity. This includes payments to suppliers, bank transactions, current debt balances, and delinquencies. Then we consider size and age of the firm. Large and well-established firms usually have lower default risk compared to smaller and younger firms. For public firms, market capitalization is used as a measure of size, while for private firms, total assets or revenues are considered. We also evaluate market conditions and competitive position. We ask questions like, are there many competitors? What is the firm's market share? Are there barriers to entry? Is the economic outlook favorable? Does the firm have any competitive advantage like strong technology or supply chain access? How much control do suppliers have over the firm? Financial market data is also useful, especially for publicly traded firms. This includes stock prices, volatility, bond yields, and valuation ratios like price to earnings and price to book. Market data is generally more useful for short-term analysis, while accounting data is better for long-term assessment. Corporate governance is another important factor. We evaluate the board of directors, independence of members, qualifications of executives, accountability, and protection of shareholder rights. Good governance usually reduces risk. Finally, corporate news and analytics are reviewed. This includes press releases, mainstream media, social media, and alternative news sources. Such information can provide valuable insights into the borrower's creditworthiness. The second step is model fitting. Here, we build a statistical model to estimate default risk. The general model form is f of x equals beta 0 plus beta 1x1 plus beta 2x2 and so on. Beta 0 is the constant term, and beta 1 to beta n are coefficients for different risk variables. The goal is to find the optimal parameter values that minimize the loss function. In mathematical terms, we choose beta star equal to argmin of L beta comma x, where L represents the loss function measuring the difference between predicted and actual outcomes. This is an optimization problem. Since default is a binary outcome, meaning either default or no default, logistic regression is commonly used. Model fitting can involve statistical techniques, data mining methods, and operations research tools. The third step is model validation. Here, we test the model on new data that was not used during training. This is called out-of-sample testing or out-of-time testing. The validation dataset uses the same risk variables but different borrowers. If the model does not perform well, we may need to redo data preprocessing or model fitting, possibly selecting different variables. Validation often requires multiple iterations. Analysts may also use walk-forward testing, where the model is trained on earlier time periods and tested on the next period, then moved forward in time. Additional validation techniques include bootstrapping and cross-validation. Another important approach is benchmarking, where the model output is compared with external ratings, such as those from credit rating agencies. The goal is not to copy the external rating, but to understand any deviations and recalibrate the model if necessary. The fourth step is definition and validation of risk ratings. After validation, the credit scores produced by the model are mapped into risk rating classes. Each rating class is associated with an estimated probability of defaults. The rating classes must be clearly differentiated from each other, and borrowers should not be overly concentrated in a single risk grade. The mapping process must also be checked over time because borrowers can migrate from one rating grade to another. If the grouping does not produce consistent or meaningful results, it needs to be adjusted. The final step is implementation, monitoring, and review. Once the model is finalized, it is implemented for real-time risk estimation and loan approval decisions. However, the process does not stop there. The model must be continuously monitored to ensure it maintains its predictive accuracy. Risk managers should identify any deterioration in performance or decline in the quality of risk estimates. If necessary, the model should be recalibrated and improved. Continuous review ensures that the credit risk scoring and rating system remains reliable and effective over time. And that completes the full credit risk scoring and rating development process, from collecting data all the way to monitoring and continuous improvement.